We're going to be doing a little ML.NET in the real world, and it's a real world sessions. We're going to bring in actually some guests. So first we have Bree Ackman, the PM on the team, and Kundan Karma from the dev team. And then we're going to bring some external folks in today. Brett Parker, the product owner at AVEVA. I'm sure I pronounced that incorrectly. And then Chris Felstead, lead software engineer at Future Sport and Entertainment. And they're going to go and talk about their experiences with ML.NET. Okay, turn it over to you guys.
Awesome. Thanks a ton, Chris. So my name is Bree. Hello, everyone. I'm the PM for ML.NET, and I'm joined here by three awesome ML.NET customers, Kundan, Chris, and Brett, who will introduce themselves a bit later. So if you don't know what ML.NET is, I'm going to go into a very brief overview of, what is machine learning, what is ML.NET, and then I want to give most of the time to Kundan, Brett, and Chris to actually talk about how they're using ML.NET. So let me change this here. So what is machine learning? This is going to be one slide. Hopefully you'll all be experts after that. But when we're talking about machine learning, we want to talk about artificial intelligence first. So artificial intelligence is machines imitating human abilities and behaviors. So this can be things like reasoning, discovering meaning, generalizing. This typically starts as a rule or logic-based system. And this can be really difficult to scale once you start having nested if statements, when you have a lot of different features that you have to use in order to make new predictions. And so that's where machine learning comes in. Machine learning is the subset of artificial intelligence where computers find patterns in data and learn from that experience to act on new data. So it's getting computers to make predictions without being explicitly programmed. And so you can use machine learning when you want to solve problems that are difficult or impossible to solve with this rules-based programming, like I mentioned with artificial intelligence. Going a bit further, we won't really talk about this much, or at all really, but deep learning is another subset of machine learning, which it's essentially a subset that has artificial neural networks that imitate the way the human brain learns, thinks, and processes data. So this can be things like image classification, object detection, natural language processing, and so on. And so what does the machine learning landscape look like right now? Externally, there's a lot of different libraries and frameworks out there. I just listed some of the most popular ones. Scikit-learn is a traditional or classical machine learning framework. And TensorFlow is used more for deep learning tasks, so is PyTorch, and these are all with Python. And then you've got Keras, which is actually an open source library that provides a Python interface for creating neural networks. It's a higher level API for building machine learning, so you can use a variety of backends to actually build those models and consume them. So this Keras actually acts as an interface for the TensorFlow library. And then you've also got Onyx. So Onyx is an open format built to represent machine learning models that lets you interchange models between various machine learning frameworks and tools. So for instance, you could train a model with TensorFlow. You could then export that to Onyx and then consume that Onyx model in a different machine learning framework. So at Microsoft, we have a few different machine learning offerings here. One of them is Azure Cognitive Services. So this is usually more pre-trained models that you can use, call a REST API, pay per request, and it works great for a lot of cases. But sometimes you need something a bit more custom. And so you can use Azure Machine Learning. This requires a little bit more data science expertise and choosing algorithms and such. This is, again, you train in Azure, and you can either call it from Azure or, in some cases, download the model. WinML is then actually just for consuming models. So you would get a trained Onyx model and then consume it on Windows for Windows applications, and you can take advantage of the GPU there. And then, of course, you've got ML.NET, which is what we're going to talk about today. So what is ML.NET? It's an open source and cross-platform machine learning framework for .NET. A little bit of the history. In 2002, Microsoft Research began this text mining search and navigation project to allow internal developers to easily add custom machine learning to Microsoft products and technologies. They developed it over many years, and then in 2011, they renamed this library to the Learning Code, or TLC. And it's been widely used within Microsoft since then, and in products like Windows Hello, Bing Ads, and a ton of other machine learning features in Microsoft products and technologies. So then in 2018, we actually took TLC, we made it open source and cross-platform. We made it a bit more .NET developer friendly. And then we released ML.NET in the first public preview at build of 2018. The following year, we actually GA'd it at the following build in 2019. And then this year, we actually had our first all virtual ML.NET community conference. So when talking about ML.NET runs essentially anywhere that .NET runs. So you can train and consume custom machine learning models on-prem in any cloud such as Azure, and of course, cross-plat, Windows, Linux, and Mac. And so when we talk about ML.NET, we really emphasize that it's built for .NET developers, meaning that you can stay in the .NET ecosystem to add machine learning to your .NET applications. And you don't need an extensive data science and machine learning background in order to do this. And the way we are able to offer this is through something called AutoML, or automated machine learning. What AutoML is it allows you to choose your machine learning scenario, input in your data, and then AutoML will go and run through a bunch of different models. So, trying out different algorithms, algorithm options, and data transformations in order to give you the highest performing model for your data. So on the base layer, we've got our ML.NET API. There's that Microsoft.ml NuGet package, which again is cross-platform. On top of that, we've got our AutoML.NET API, which implements the AutoML that I just mentioned. And then our tooling runs on top of that. So we've got Model Builder, which you might have seen demos done before. I think we had a demo last year in .NET Conf Keynote. That's currently just Visual Studio. And then we got the ML.NET CLI, which is our cross-platform offering there. All right, so what can you do with ML.NET? So these are some of what we call machine learning tasks. So you can train and consume models for classification. So this can be things like, I want to categorize email as spam or not spam. I want to classify law documents. I want to take in, incoming stream comments and see if they're negative or positive. Then there's things like regression, where you can do price prediction. I want to determine the price of this car based on, how the mileage, the year, the make, and the model. Another one is forecasting, so you can predict future sales based on past sales. This is a really common business scenario here. And you've got anomaly detection. This can be things like, identifying if transactions are fraudulent or detecting network intrusions. Then you've got ranking, so this could be things like search results ranking. Clustering would be things like customer segmentation. Recommendation would be things like product recommendation. And then moving into the deep learning space, you've got image classification and object detection. So these are all tasks that you can accomplish with ML.NET, whether that's training or consuming models. So when would you want to use ML.NET? So the main thing is if you want to stay in the .NET ecosystem for machine learning, that's a really great reason. If you don't want to worry about the low-level complexities of machine learning, or you want to train a custom model where a pre-trained one might not fit your use case, or if you want to consume a pre-trained model, say that you're working with data scientists who work in Python, they train the model using PyTorch or TensorFlow, convert that to Onyx. You can then actually consume that Onyx model with ML.NET in your .NET applications. So yeah, that was my quick ML and ML.NET 101. I actually want to turn it over to Kundan, who has some slides as well to talk about, to introduce himself first, and I'll talk about how he's using ML.NET.
Yeah, thanks, Bree. Hey, thanks for joining. My name is Kundan Karma. I'm the Senior Software Engineer at Microsoft and works for Microsoft Real Estate and Security Group. So Microsoft RENS Group manages one of the most complex facilities infrastructure globally with 1,116 buildings and data centers in 112 countries. RENS Group manages everything starting from the food preparation to the bus maintenance to the furniture ordering, lighting, electricity, heating, ventilation, air condition, everything. So to keep the campus and Microsoft facilities running smoothly is a large undertaking. For that, we rely on the smart building automation. It helps us to manage and control the heating, ventilation, and air conditioning and lighting systems. And if we talk only about the North America Puget Sound, we have 100 plus buildings and we have 33,000 plus HVAC devices. And all of these are IoT equipped HVAC devices. So we have a strategic partnership with Iconics, which actually gathers all the telemetry information from the IoT enabled HVAC devices. And then using the rules, it will scrutinize and do the first screening, and it per day on an average receives 49 million IoT faults from the Puget Sound, North America. And we have a facilities management which is totally been built on the Dynamics 365 platform. So let me show you how we roll out our first integration and what are the challenges we face and how all these challenges been overcome by the ML.NET. So let's get to understand. So this is the integration which we have done. We have all the HVAC devices equipped with IoT sensors on that, and we have a facility management which is on the Dynamics 365 field service module. And then all the HVAC devices emit the telemetry information and being collected by the Iconics, which use the rules and then to identify that it's a right fault or not. And once it identifies it as a fault, it will transfer that fault to the Dynamics 365 platform. So here we connected our integrator. We created IoT integrator, so which is built on the Microsoft Azure platform as a service. And then here we extract all the faults from the iconics and push them as an IoT alert into Dynamics 365 field service. So once we done this integration, once we roll out and slowly we started onboarding the buildings, we stopped ourselves after onboarding the 13 buildings. We could not onboard more than 13 buildings. What are the problems we face? Let me show you. So once we onboard the buildings, what the pattern we understand that every building is emitting a 2000 faults per day to our Dynamics 365 platforms. And if you could imagine, if we think about the 100 plus buildings only in the figures on North America, we would have get on an average 200,000 faults per day into our system. It would not only overwhelm the Dynamics 365 database, but all the technicians and the users globally connect to the system. It will hinder their performance as well. So apart from that, the major thing is, if we receive such a huge amount of IoT alerts into our system, it would be very hard for the field technician to go and review all these faults and identify them to convert it into work order. So once it is created a work order, then only the field technician will go to that HVAC device and fix that device. So to solve this problem, definitely data science and machine learning was the primary focus for us. But because our team has a .NET expertise with them, we went with the ML.NET. Okay, so let me show you what are the changes we done to our integration. So this is the HVAC devices, IoT cubed, and our facility link on Dynamics 365. So in the connector, we introduced the ML.NET machine learning model. This machine learning model totally mimic the performance, totally mimic the behavior of a technician. So whenever the fault get received, it first review the whole fault, identify that it should be converted into work order or not. Is it to be converted or not? If it is not, it will go ahead and convert into a work order and IoT alert into Dynamics 365 platform, or keep it into the Cosmos DB database. And then it will be very easy for the technician to go and review into Dynamics 365 platform and convert into a work order easily. Okay, so let me tell you what are the impacts the ML.NET bring to us. The first impact is we could safely onboard the 100 plus buildings easily. And once we done and roll out this for the whole buildings, what we identified, it reduced the 70 to 80% of the fault into our Dynamics 365 platform, and it removes the noise from the platform, so that the technician can majorly focus on the right alerts and can identify them to be converted into a work order. So apart from that, the major advantage what the ML.NET given to us is the automated CI/CD. So it's not like we just created a model and we are doing a manual deployment. No, it's a full automated process. Because it's a whole .NET technology in place and we have a .NET expertise with us, we created a full automated deployment starting from the model building, training, unit test cases. If you see on the left hand side, this is the full CI pipeline where all the model building, training, and then the unit test cases we are running, and then packaging into a service. And then finally on the CD pipeline, we are deploying this model as a Azure function and the services. So apart from that, let me show you one more thing. Like this is our subset of the telemetry dashboard from the production. You could easily see on the middle of the side, this is the number of faults received by the machine learning model. And here, these are the number of faults which are identified to be converted into a work order into our D365 system. There's a clear 70 to 80% reduction we could see from the live telemetry dashboard. Yeah, this is all. If somebody want to read detail about this, you can find it on the ML.NET Customer Showcase blog. Thanks a lot, and back to Bree.
Awesome. Thanks, Kunan. That was really, really awesome. It's great to see how ML.NET is being used internally at Microsoft and other groups. But now I want to see some external use cases. So Chris has prepared some stuff. He'll share a screen. And Chris, if you want to introduce yourself and tell us how you're using ML.NET.
Thank you, Brie. Yeah, I'm Chris Felsted. I've been a developer now for about 20 years. And I'm currently employed at Future Sports and Entertainment. Basically, we work with the world's most famous clubs, federations, and sponsors, and we use a variety of sort of in-house techniques and proprietary software in order to track exposure for rights holders and sponsors. So we will work with clubs like Manchester United or federations like the NFL, Major League Baseball, London Marathon, and such like. In order to track the exposure and the value of a sponsorship deal, we need very accurate data as to when that sponsor appeared on the screen, how long they appeared on the screen, what was the quality of the exposure, was there other sponsorships around it, and such like. In order to do that and to get the most accurate data, we actually process the footage from sporting events. So we will be able to track, for instance, a logo on a player's shirt. We'll be able to know what the logo was, the fact that it was on a player's shirt, how long the player was on the screen, and such like. In order to do that, we will actually process hundreds of hours, millions of frames every month of video footage. So when we get the footage, we have two routes in which we can very quickly analyze and get the specific data out. We either use Azure Computer Vision, and we use their sort of OCR read API. And then that enables us to, with literally zero training, get a simple subset of data back. It won't tell us whether it was on a player's shirt or an LED board, but what it will do is, if it's a very textural logo, we'll be able to get a rough analysis of how often that brand was on the screen. Most of our scenarios, however, we need a richer data set. So we might be dealing with logos like the Nike swoosh, in which case that's not going to come up in OCR. And we might have a sponsorship deal where the sponsor appears on multiple surfaces. So again, it could be an LED board, it could be a goalpost, it could be a player shirt, it could be a car. And we need to be able to determine not only the fact that the logo appeared, but what it appeared on. So with custom vision, we are able to export using an Onyx model, much as Bree alluded to earlier, an Onyx model of what we have created in custom vision. So if we've got a static model with very few tags, so we're only dealing with perhaps one sponsor in this case, and we're going to do, say, a social media campaign, we're going to have a large number of images from social media that may or may not contain the brand. The brand is only going to appear in a couple of different varieties, and we're focused on one area. Now, if we were to run that through custom vision, that obviously comes with an expense. But what ML.net does is it allows us to take that model out and run it where it's most cost effective for us. And it gives us the ability of embedding that model inside a web application, such as a portal that we'll give to the client, or a mobile application, or any number of our in-house pieces of software. And we can then take that data that we've processed through ML.net and feed it back up into custom vision, revise the model, and then bring it back down again with iterative updates. In order to sort of give you an idea of what's going on and what we do, I've spent literally a couple of minutes throwing together a demo model for you. This isn't going to be entirely accurate because, like I say, I've literally spent a couple of minutes on this. Our analysts would usually spend a few hours training a model. But if I just show you a sample of what we're able to get, this is not using custom vision at all. This is using a Onyx model that we've downloaded, and we're going to process an image simply through ML.net. And if I hit the predict icon, and the demo gods are hopefully good with us today, we are able to see in this particular image, I've managed to get a number of labels back. So we can see I'm tracking a T5G logo on the pitch and a Kia logo on some LED boards. We're able to obtain a confidence score. So obviously, when it picks up stuff of a lower quality confidence, we can filter out any of the noise. And we're able to get coordinates from the left, the top, the width, and the height. So we're able to see where on the screen that has appeared. And then with a simple sort of screen overlay, you can see here, we've got 4 Kia LED boards and 1 T5 pitch. And you can see from the image below, we've got 4 boxes. So we can see on the image exactly where that's come. And that's really it. So I can hand back to Bree.
Awesome. Thanks for sharing, Chris. That's a really awesome use case of deep learning. And also, integrating different machine learning Microsoft technologies together. So now I'm going to hand it over to Brett. He'll share a screen and talk about his use case.
Thanks, Bree. My name's Brett Parker. I'm a product owner at AVEVA. And specifically, I'm a product owner in AVEVA's 3D software. So it's a product called AVEVA E3D Design. So who are AVEVA? AVEVA are a multinational industrial technology company. We provide a range of software from engineering, 3D, 2D, design, and information management software. We cover all industrial software, the full asset lifecycle. So whether that be the 3D and 2D design at the beginning, material management, some of the data analytics at the end, and everything you can think of that kind of goes into the industrial software business. We provide software for a number of different industries, specifically some of the ones that I mentioned there, but chemical, oil and gas, water, steel fabrication, and obviously many more. So why ML.NET? Well, AVEVA are open to a number of different third-party tools at the moment. So we're looking at obviously ML.NET. We see things like TensorFlow. We also have our own patented and developed software. So there's a number of different tools that we're currently looking at. And where ML.NET specifically fits in my case with AVEVA E3D Design is the existing code base. So we have an existing C# and .NET code base, and ML.NET seamlessly transitions with that. The simplicity of ML.NET, and specifically how simple it is to get ML.NET into existing products, allows us to rapidly prototype ideas, get things quickly into testing phases, allows us to quickly see whether or not what we're actually thinking of is worthwhile in investing in. So where can AVEVA specifically utilize ML.NET? Well, at the moment, in the product that I'm specifically looking at in AVEVA E3D Design, we're specifically looking at how we can do suggestive design. So how can we predict what information the user needs to see? As with many softwares, the user doesn't need every part of the software all at the same time. So displaying information, whether it's changing an icon to the icon that they need at that moment, or predicting a certain piece of information, or just giving them a helping hand, anything that we can do to increase the user's productivity, increase how they interact with the product, and also ultimately increase their productivity for the deliverables that they're trying to produce and help our customers. A perfect example of what we're trying to achieve here is something like predictive text. If you think about what predictive text does, not only does it kind of help you along in terms of giving you shortcuts to like get the next word, for example, but it also improves your consistency. Certainly from my point of view, my spelling was absolutely terrible, and now it's got better with the help of things like predictive text. So I'm more consistent now in my spelling, and that's the kind of thing that we're trying to potentially utilize ML.NET for. So what impact has it had at the moment? Well, we're in very early stages at the minute for our development, and ML.NET is one of the tools that we're looking at as to help us. But from a product owner point of view, that ability to rapidly develop and prototype something, to just have an idea, very quickly be able to put it into our product, put it into the product, see what it looks like, trial it, is it actually what we're looking for? If you think about ML and AI of what it is in general, you don't really know what you're going to get with an AI or an ML model until you've actually got there. So you don't want to spend lots of time, lots of effort, lots of energy developing something that potentially is not the outcome you want. And being able to rapidly do developments in ML.NET is one of the biggest benefits for us. Again, it comes down to our native code base. So with an existing .NET and C# code base, it feels perfect. It feels familiar like any other code base. And it just feels like another C# library that we can get used to. We don't have to go down this massive journey of learning Python or other kind of languages or more of the complexities around AI. It just feels natural. And specifically, one of the biggest benefits for myself is the community. So Bree and the team at Microsoft have been fantastic in helping both myself and AVEVA, but also some of the people outside of Microsoft, such as Alexander Schlott and John Wood. They're kind of help and guide in hand, and the willingness to actually be able to ask questions has really helped in picking up ML.NET. And that was a quite quick whistle-top tour, but with that, I'll pass back to Bree.
Awesome. Thanks, Brett. And I'm super excited for you to get closer to production and when you are able to actually demo this stuff. I've seen it behind the scenes and it's really, really cool. I want to show my screen real quick just to show you all what's coming up, and then we'll answer some questions. So here's some things that we've got on our roadmap. You can take a look at it, some things that are really exciting for me personally or I think are the most exciting. We've got our ML.NET Hackathon coming up this Friday. We're working to add ML Ops integration for ML.NET, add a bit more model explainability, adding all of our local and Azure scenarios for AutoML and into our tooling, and making sure that ML.NET runs everywhere the .NET runs, including Blazor, WebAssembly, mobile, and IoT. So I'll leave these resources on here. You're welcome to reach out to any of us on Twitter. Tech lead here is Chris, and then I've also added their company's ones here. Just a reminder about the hackathon, and just if you want to get started, if you haven't yet, or just some resources right here. So with that, we've got about 3 minutes for questions, if there are any.
Thanks, everybody. I really appreciate the real world examples. That was really cool to see some of that stuff. That's some really cool looking stuff that you guys are doing. And if we have time, I actually want to ask you guys what you guys will be doing next. But first, we'll go to the tag board. We got one question from Bagaloo Dev, like that name. Is it possible to train model for automatic number plate recognition, ANPR, system that runs outside standalone?
I'm not sure what outside standalone really means. I do know that actually ScanCam is a company in Australia that is using ML.NET for object detection, where they have at a bunch of fuel stations or gas stations, as we call them here. They use IoT cameras to capture first vehicles, and then they use ML.NET for object detection again to detect the license plates. They use a separate OCR technology to get the numbers and letters, but they're using it to prevent fuel drive-offs, because in Australia you get your gas and then you pay. So if the ML.NET detects that you have been there before and you're a previous offender, you actually have to go in and pay beforehand. So yeah, that type of scenario is possible. Nice.
That's a pretty smart. Yeah, no more dine and dash or gas and dash, I guess they would be.
Yeah, exactly.
Excellent. Okay, for Brett and Chris, those were some really cool solutions that you guys have been developing. What's next? Like, what are you guys working on? Either as an extension of those current projects, or what kind of projects are next on board for your organizations and problems you're looking to solve with ML and ML.NET?
For us, at the minute, we're currently working on just re-engineering some of the existing technology just to make the lives of our analysts a lot easier. So some of the processes we've got at the minute where we're just recently consuming all this Azure data, we need to bring the other processes sort of up to speed with the new data sets. So that's our focus for the next sort of couple of months. Also, we're trying to get a bit more throughput out the API. So we're trying to literally use the entire amount of sort of transactions per second we can. So that's the main focus at the minute. It's sort of performance and tooling. Shortly after that, it's going to be even more so for us using previous results and OCR results to train the custom vision models that we're using. So obviously at the minute, that's the largest time consuming step. Whereas if we can take data that we've already got from, say, previous seasons, previous sporting events, or even sort of OCR runs, it can help us with our bank of exposures, just literally automatically train the model. So again, that will reduce our analysts' time, and we'll end up hopefully in this nice place where there's actually very little training, even of a custom vision model. It will just be a case of, selecting what you're looking for, and it will automatically generate that model for you.
Got it. Very good. Go ahead.
From AVEVA's point of view, specifically in the AVEVA E3D design point of view, we're now really excited to see where it goes, basically. We're in early stages of development. We don't really have a specific thing that we're working on. We're working on a multitude of things. And we're really excited to see where ML.NET takes us, really. I mean, it'd be great to try and interact with some of the 3D side of the software that we have. And I've had discussions with Louise and Bree around that. So yeah, we don't know specifically where it's going to take us at the minute, but we're really excited to see where it can help us.
Awesome. Very good. Very good. Okay, looks like we are out of time. I'd like to thank our folks from ML.NET team, and then our special guest, Brett and Chris, for taking the time today, come in and really tell us about the real world customer experience. And that's been super, super useful.